Lesson 98, making graphs and using equations of ellipses. This is a lot of information, so if you take really good notes, you should be able to come back and look at them and follow examples and all that stuff, okay?
Yes.
The definition of an ellipse is a set of all points, P, in a plane such that the sum of the distance from P to two fixed points, f sub 1 and f sub 2, is constant. So if you notice, it's very similar to a circle, which I started writing because I said it. Dang it. But a circle is fixed distance from one point. An ellipse is a fixed distance from 2 points. Okay, so we're going to just draw a picture here. Well, I didn't draw a very good one. Dang it. There we go. Here's your two foci. So we have this would be 1. Remember when we pulled that taut, this would be another. So P sub 1, P sub 2. Here's a point, P sub 1 and P sub 2. So the sum of the distances, so if you take the distance here to P1 and the distance here, it's going to equal the sum of the distances that P2 is from those two. So these two will equal those two. And I don't want to write that out here, but I have it written out in my notes, but we're not going to. Tally?
So, how do you decide where the points go along the line?
It's all the points. Like these P1 and P2? It's any point. Just pick one.
No, the ones on the...
Ah, we're going to talk about that. Yep. So like this distance, if you add those two, it'll be the same as that one, etc. Let's not ask questions because I'm gonna teach it to you. Let's not. Okay, so here, and I said.
I know. I'm just kidding. I'm sorry.
Okay.
Shutting up now.
Okay. A will be greater than B. Okay, so this is like a standard equation for an ellipse that is this way, like anyway, this way.
Horizontal.
Yes, thank you. Horizontal. This point is 0, B. This point would be 0, negative B. So if you take the square root of B squared, you will find half the distance of the minor axis. So between 0B and 0, negative B, that's called the minor axis. And then you have these 2 points, A0 and negative A0, and this is called the major axis. And then your foci are equal distances from A and negative A. So we'll call this one C0 and negative C0. And I feel like at some point in the lesson I'll teach you how to find C, but I can't really. Maybe I don't know right now. Okay. The major axis is horizontal in this one, okay? So this is when A is greater than B, and you'll always have the greater one under the x squared. So if we had x squared divided by b squared plus y squared divided by a squared, and b equals 1, and b is greater than a, then we'll have a vertical major axis. So let's just kind of draw it this way. Oh yeah, so this is 0, a, negative a, 0. This one is b, 0, and negative b, 0. This is where your foci would be. So the major axis in this one is vertical. Okay, absorb, absorb, absorb.
Don't
Finish
go
writing.
negative A, 0. It shouldn't it be 0, negative A?
Probably. Yes, thank you. Oh, we call the B, like the vertices on the end of the minor axis. Okay, so we'll write this part down. Vertices on, whoops, I should have wrote endpoints. Oh well. Vertices on end of minor axis are called covertices. The major axis, the endpoints are just called vertices. So the minor axis gets like second, they're co-vertices. They don't get to have their own. Okay, aha, here's how to find C. No wonder. Oh, okay, so C, I'm just gonna tell you this. I'm turning the page. Can I turn the page?
No. Yes, do it. Just do it, it's fun.
No.
It's fun to see them. No.
Okay, C equals the distance. It's like a distance formula. So it's a square root of a squared plus b squared. Okay. Eccentricity. You have to know what eccentricity means. And it's a lowercase e, different than the inverse natural log.
You told me this morning it was eccentricity. I said eccentricity and you're like eccentricity.
Eccentricity. No, I've never said eccentricity. I have no idea what that means.
You're like,
That's the measure of its curvature. Okay? So the eccentricity tells if it's like curvy, like closer to a circle, or more oblongy. And stuff.
Oh, that is useful to have an apostrophe. Because it's possessive,
Oh.
not equal.
Oh, if it's possessive, I thought you had an apostrophe.
No.
Oh, okay.
The apostrophe means it is.
Oh,
It
that's.
is curvature.
I just don't know. I thought possessive. But I thought if something's possessive, you put an apostrophe S, like Holly's
You're
room.
saying the thing, this is, it's is not an
No,
actual
we're
name.
talking about it, not a person.
Yeah, but it belongs to it.
Well, we're in math,
That's
not
it.
grammar.
Yeah, I was like, how about we skip the English lesson?
All right, we'll
Yeah.
figure it out.
Lesson.
Where C is the distance. Well, you guys know what, I don't know how to spell distance.
Distance.
Now you guys have me all like
Distance.
languaged out. Okay, where C is the distance from the center to a focus, and A is the distance from the center to a vertex. Remember, the vertex is the endpoint on a major axis. Put in parentheses, endpoint of major. Okay, so if you have a full circle, just a circle, that means all the two foci are right on top of each other. The eccentricity is 0. And if you're talking about an ellipse, the eccentricity will be less than 1, greater than 0. If it equals 1, it's just a straight line and doesn't even make sense. Okay. So we are going to graph and find the values of A, B, C, and E for an example here. So we have this x squared over 3 squared plus y squared equals 1. So 3 is under the x, so that means that's A. Okay, so A is 3. Wait, why couldn't it be B?
No, it's the same sign.
Uh-oh.
Oh, it's if A is greater than
Okay.
B. So
And B is 1. C is the square root of those two squared and subtracted, which is, what is this, 9, 8, so 2 root 2.
you said it's plus up there.
Where? What?
Up there it says plus.
Oh, that's what I meant. No, that's not what I meant.
Then it's
No, this should be minus. Who put a plus up there?
I did, I'm
That doesn't
sorry.
even make sense.
Yeah, I just derived it and it was minus.
Dang it.
I'm sorry.
Did I say minus and write a plus?
No, you
No,
said
you said
plus.
plus.
Oh, that's because I was thinking distance, and I think distance we add, don't we? Dang it. 2 root 2, which is approximately 2.83. That's our C. E is C over A, which is 2 root 2 over 3, which is approximately 0.94. So it's pretty squishy. And we're going to graph it. So our major axis is along the x-axis. Okay. B is 1, so we come up 1 and down 1. C is 2.83, so really close to the eccentricity is 0.94, which basically just says it's pretty oblongy or whatever that word is. Oh, that looks beautiful. That is an ellipse.
I think
Wait, we're not done?
Pictures.
Oh boy. Now, if it's shifted and changes and all that stuff, it looks like this. X minus h squared plus y minus k squared. Oops. And the first one is over a squared. The second one is over b squared, and it equals 1. Ellipses always equal 1. Or it could be, oh, I know where I made my mistake. Y minus k squared over a squared plus x minus h quantity squared over b squared equals 1. There's the mistake. Okay, come back. We're switching back a page. I know exactly where my mistake is.
Can you graph this on the graphing calculator?
That should not be an x right there. This should be a y. That's the problem. Right here. Do you see this where I had the x squared over b squared? This actually should be y, and that should be x. That makes more sense, right? Because then y, that means the longer side.
Yeah, 'cause it's long and the other one's short.
Wait, but then
But
it's
then-
the same as
That's
what it was
the same
before.
as the other equation though. It's just,
No, it's just
Oh.
reciprocal.
Wait, why? What?
But then
Oh.
it's just exactly the same.
Now I'm confused.
I think it was the same.
No, but B is greater
had
than
it right
A
the
in the
first
second
time.
one.
Right.
But
Yeah.
b is greater than a in the second one.
Yeah, and A
So-
is greater than B in the first
Yeah,
one.
so like even if you wrote it this way, okay, here's the clue. If you write it this way, which you can always, If B is bigger and it's on this side, it still goes this way. And I believe this should be B. Oh my goodness. What? I almost said your mom, but your teacher, your mom is something else.
Well, you are some of us.
Yeah, that's true. So this is A and negative A.
Oh, that helps.
Now it's looking more right. I was writing it thinking this does not look right, but I'm just gonna pretend like I know.
Wait, but that's still the exact same equation as the other one.
Exactly, it's exactly the same. But if B is bigger than A, it will look like this rather than this. That's all.
So it doesn't
That's
have to
the
depend
only
on the
difference.
equation.
Yes.
Oh, you just switched them, so I can just keep it how it was.
You really can, and just say if B is greater than A, it looks like this. Tan, pay attention. Quit bugging him.
No, he's not bugging me.
Okay, so back,
Writing on this
I'm
board.
turning the page, and I'm sorry if I got you guys all messed up. Ben, you really should put that away, and your watch is not allowed to be on your hand. So we have the center, that'll be on my video. I forgot. Is at HK. So previously our center was at the origin. The vertices will be at, and this is if A is greater than B. The vertices will be at H plus A, K, and H minus A, K. So in other words, you're just shifting everything over. And then the foci will be at H plus C, comma K, and H minus C, comma K. And the co-vertices, H, comma K plus B, and H, comma K minus B. And then if B is greater than A, so this is A is greater than B. This one is B is greater than A. Wait, why did I switch?
That switched.
This is wrong, isn't it? I switched it over. There we go.
But it's not, it's the same before.
What?
Yes, it is.
No, it's okay.
It's okay, it's just the community property.
It's just the same thing.
Yeah.
The center is HK. The vertices now are H, comma K plus A, and H, comma K minus A. This one is H, comma K plus C, H, comma K minus C, and then this one is H plus B, comma K. Oh boy. H plus B, comma H minus B, comma K. Ugh. Now, I would write an example of this in the notes, but I'm not going to because it's already like 20 minutes long or something. So I'm ending the whatever